Reminder at the cells that we've looked at so far. Well, we've got the pancreatic acinar cells that we've talked about that secrete proteins, that secrete zymogens and lipase and sodium chloride for isotonic fluid. We've got the centroacinar cells, which are the sort of first cells that you see when you enter the intercalated ducts. Pancreatic duct cells, they line the ducts, and also these goblet cells that we haven't talked about yet, that they're mucus secreting. So first looking at the acinar cells, well, the function of them, as I've said, is the production and export of large quantities of protein via the rough endoplasmic reticulum secretory granules, which they exocytose at the apical pole. Now, the important thing is, the first concept that we need to understand is that there's low levels of secretion when it's unstimulated. So even if the pancreas, the acinar cells, are not being stimulated, then there's still a constitutive secretory pathway. Constitutive means always active, and this causes a low level of secretion. Now the next thing to look at is, well, what stimulates the acinar cells? We know that they're constitutively active, and there's always a low level of secretion, but what actually stimulates the acinar cells? Well, they're predominantly stimulated through cholecystokinin, and if you remember back, cholecystokinin comes from duodenal eye cells. Acetylcholine comes from vagal stimulation. Remember, this acetylcholine acts on the muscarinic receptors. Cholecystokinin acts on cholecystokinin receptors. So acetylcholine and cholecystokinin, they activate the PKC pathway, by which the intracellular calcium increases, and therefore we know that when calcium increases, it causes the secretion, it causes exocytosis. So you're going to get an increased enzyme and chloride secretion from the acinar cells. But it's not just acetylcholine and cholecystokinin that activate the acinar cells. It's also VIP, which is vasoactive intestinal peptide, which is another hormone, and secretin. Now secretin, if you think back, it comes from duodenal S cells. Secretin, S for secretin, eye cells produce cholecystokinin, vagal stimulation releases acetylcholine. So the duodenal S cells, when they're stimulated, they release secretin, and VIP and secretin, they activate a different pathway. So not the PKC pathway, they activate the adenyl cyclase PKA pathway, which is less. This is the predominant method. This is the slightly less predominant method. This is the secondary method, and this also results in increased enzyme and chloride secretion from the acinar cells. Another important thing to note is that when VIP, secretin, acetylcholine, cholecystokinin, when they act on the acinar cells, they involve G protein coupled receptors in order to activate this adenyl cyclase PKA pathway and PKC intracellular calcium pathway. So now that we understand that cholecystokinin is the main method by which the acinar cells are stimulated, well, what causes the release of cholecystokinin from the eye cells? Well, if you remember that eye can be associated with fat. So let's have a look at that. Well, fat stimulates the duodenal eye cells to release cholecystokinin, and cholecystokinin, by this PKC pathway, it then stimulates the pancreatic acinar cells to secrete their zymogens. And well, so we've understood that fat stimulates the duodenal eye cells, but how exactly does fat stimulate the duodenal eye cells? Well, the way it stimulates the duodenal eye cells is indirectly. It's through this thing here. It's called luminal cholecystokinin releasing factor. And as you can guess, luminal cholecystokinin releasing factor causes the release of cholecystokinin from duodenal eye cells. Well, how does that work? Well, in the fasting state, so you haven't eaten anything, you still have digestive enzymes, don't you? So this constitutive activity is still producing digestive enzymes. And therefore, luminal cholecystokinin releasing factor is degraded by these digestive enzymes. So it can't stimulate the eye cells to secrete cholecystokinin. However, in the fed state, you've eaten food, you've got a lot of chyme, and therefore the digestive enzymes, they're, instead of degrading the luminal cholecystokinin releasing factor, they're acting on the chyme. So the luminal cholecystokinin releasing factor, LCRF, is not degraded, And if it's not degraded, then it can stimulate the duodenal eye cells to release the cholecystokinin. And cholecystokinin, as we talked about there, through activating the PKC pathway, it will stimulate the acinar cells to secrete proteins. So if we look at that as a whole, well, what's happened? Well, you've eaten. If you've not eaten, then you're not going to get enzymes secreted from the pancreas, which makes sense. But if you've eaten, it's going to cause, through this luminal cholecystokinin releasing factor pathway, it's going to cause the acinar cells to secrete the proteins and the zymogens and the enzymes necessary for to deal with whatever you've eaten. So, luminal cholecystokinin releasing factor stimulates cholecystokinin through which then acts on acinar cells to release to secrete their zymogens and lipases in the fed state. So if we look at that as a whole, well, so when you've had a fatty meal, the digestive enzymes are going to be acting on the meal, the chyme, instead of the luminal cholecystokinin releasing factor. So it's not going to be degraded. The LCRF is not degraded. So it's going to cause the secretion of cholecystokinin from the duodenal eye cells. Remember, fat acts on eye cells indirectly through this LCRF. So the duodenal eye cells, they release cholecystokinin, and through this PKC pathway, they stimulate the acinar cells. And one more thing, it's slightly less important, but the fatty meal, they also cause a rise in cholecystokinin via CCKA receptor or parasympathetic nervous system stimulation. And so essentially, the fatty meal, it stimulates the acinar cells to release their protein and lipase, zymogen and lipase secretions. And if we have a look at the sort of a summary of the concept, well, the fatty meal and luminal cholecystokinin releasing factor causes cholecystokinin release, which causes acinar cell stimulation. Now, I also said that acinar cells secrete, not only do they secrete enzymes, lipase and zymogen, which is a proenzyme, they also secrete sodium chloride for hydration. So it's got the same stimulants, VIP, secretin, acetylcholine, cholecystokinin, and these, through the calcium ion, the PKC pathway, cause sodium chloride secretion from the apical chloride channels, which hydrates the proteins that it secretes.